Hello and welcome to this short ISTA video. The plan is to give you some tips and hints that will help you in your study as you revise towards this year's LC Physics exam. My name is Paul Nugent. I am a physics teacher and I want to get started straight away. So, practice doesn't make perfect, but it does make better. The more you do, the easier things become. As you revise, you need to focus in on your notes, but there may be a lot of work in that, so you need to make summaries. The more you summarize, the more you compact, the better. Try to be logical. Physics is a logical subject. If you don't understand it, it's going to be very hard for you to be familiar with it, and it's going to be very difficult for you to remember it in an exam situation. Try to build connections between the different topics. For example, a charged particle entering into a magnetic field displays a circular motion. So that brings you out into the circular motion equations. The more connections you can make within physics, the better it will be. Mind maps are a great resource for actually summarizing and getting the overview of the different topics. The key to leaving cert physics is really now at this stage in the past papers, doing lots of questions, checking the marking schemes. But be careful. The marking schemes are not model answers, they are marking schemes, and are so they are very much precise. They're designed for markers. You will need to build up on your answers and make full sentences out of them, not just key words. As you revise, make sure that you check in with yourself and ask questions of yourself. What have you learned in the last 30 minutes, etc. In this time up to your exams, be careful about your exercise. Make sure you're getting enough rest. Don't do anything that may put you at risk. The last thing you want is a broken hand or something that's going to affect your exams. As you go through your revision, put together some notes that will be for your last minute or the night before revision for you. That night before your exam, you're not going to get much done because you're going to probably be tired, you're maybe going to be anxious, but if you want to revise over some material, make sure it's something that you are quite familiar with. What we're doing here is at the end, you will see a QR code which will bring you to some resources that you may find useful. The link to them is there on the bottom of this slide. Okay, I've broken up the syllabus to what I call the 4Ds: diagrams, definitions, derivations, and demos. These are really good starting points for you to tackle the work that's ahead. A word about diagrams: wherever you can draw a diagram, you should. Make sure it's labeled, it's clear, it's large. It needs to be about 1/3 of the size of the page. You should use some simple shapes like squares, rectangles, circles. It doesn't have to be an artist's impression. It does have to be clear though. A few coins in your pocket of different sizes may help in drawing those circles. If you can't draw a straight line, as many of us can't, then a ruler may be necessary. Under no circumstances should you think of coloring or shading in. There's no extra marks for being very artistic in this exam. When you're drawing diagrams, you use a soft pencil or a friction erasable pen. Your papers probably will be scanned by a scanner, so you need to be very, very careful that whatever you write on the page is very visible, not faint. Okay, the second D is definitions. Make sure you know these. They're the backbones of your learning. And it has been calculated that between 12 and 17% of total marks can be scored from definitions. And don't necessarily try to make up your own definition. You need to have all the essential information in it in order to get the full marks. So my advice is to be familiar with the definitions either from your textbook or from your notes. It is possible in some areas to give a formula as a definition from the maths tables, but make sure you state what each letter represents. If you don't, you will certainly lose maybe 50% of your marks for that definition. Our next D is derivations. 11 of them are on the course. There are usually one or two of them appear each year, and if you have practiced them, this can be an easy 12 marks. If you don't practice them, they can be very difficult. Of course, as you learn the skill of deriving a formula, you will also be able to maybe derive unseen definitions that may come up on the paper. The demonstrations or demo experiments, they usually appear in section B rather than section A. Do use a diagram to answer them. Diagram is worth 1,000 words at least, maybe more in a physics exam. There will be an unofficial list of the demo experiments in the resource drive. Maths tables, okay, physicist's best friend, okay. If there's no sign of them coming in the exam, if you started your exam and the superintendent hasn't given out the papers, make sure you ask for them. At this stage in your revision, know what's in the book and what's not. Also in the resources, there are a list of formulae that are not in the maths tables. Be able to find information quickly, but also for each formula, know what the symbols and letters represent in every single one of the formulas. It's no good just being able to get a formula and write it down if you don't actually know what everything means in it. Okay, of course, if a formula lodges in your memory, don't fight it. It's going to be faster to use it from your memory than to look it up from the maths tables, but the maths tables are there in case you're not sure. Okay, let's get familiar with the paper and what to expect. It's a 3-hour paper. There are 400 marks. What you need to do is get as many marks as possible in those 3 hours. Okay, there are allowances for COVID again this year, not as great as in previous years, but basically what you have to do is you have to do the same number of questions as per normal, but you do get more choice. Now, this is a double-edged sword. More choice means that you have to do more reading to decide on your questions. And choosing your questions is very much a strategy that you need to get right. So practice it. Look at old exam papers and pick out the questions that you prefer to answer. The current syllabus is over 20 years old, and so a lot of the questions do repeat. Some students have asked me in the past, would they leave out sections? Research would suggest that students that get their H1 have not left out large sections of the course. And particularly in latter years, the SEC are mixing topics within the questions. So if you've left out a certain topic, you may find that there's a question you can't do because it does have that mixed topic in it. Okay, on the slide, you will see a breakdown from last year's paper, which is fairly typical of the spread from the different topics. So you can see the big sections are electricity and modern physics. These do include the option questions. Okay, mechanics is important as well, temperature and heat, and you can see that breakdown there and also where they appear. Okay, section A. These are the mandatory experiments. You do 3 out of 5. They're based on the 24 experiments that you will have covered in your last 2 years. Be prepared again for mixed questions where you get a question that's based on more than one experiment. There are 120 marks going for this. 30% of your total mark can be achieved here. You should aim to do exceptionally well in this section. Revise the experiments under these following titles: the diagram, be able to draw it, the method, you can use bulleted points, the formula associated with any of the experiments, graphs, precautions, and accuracy. Make sure that you're able to work out a percentage error for each of the experiments. Graphs, I've mentioned them already, but they are hugely important. You'll definitely get them in section A, and in section B, you may be asked to sketch a graph. Now, with that sketch graph, I personally would still use graph paper. I would make it as large as possible. I would use the ideas that I would use in section A. Make sure you know the expected shapes. Is it a line? Is it a curve? Does it pass through the origin, or does it have an intercept, which is not the origin? There will be a related formula with each of the graphs, quite possibly as well. Watch out for this keyword, suitable. Suitable indicates that you need to modify the data. You might need to square a periodic time, or you might have to go 1 over it. Make sure that you know what has to be done with the data, and your keyword is when you see suitable. Your graph paper, you need to do your graph on graph paper. It needs to be large. You do need to use a ruler, a single line, a pencil, or an erasable pen. Put salt on your graph. That stands for scale, axis, label, and title. If it is a straight line, make sure you use the concept of a best fit that goes through the data space rather than joining up single dots. And make sure that you know how to find the slope of a line, rise over run, or using the slope formula. When you're finding a slope, make sure you use points that are far apart on the line. Watch out for when it asks for use your graph. Don't use a point that's in the given table. You may lose marks because the thought here is that you're not using your graph, you're using a data point that was given to you. Section B, these are the concepts and the definitions, also calculations, science, technology, and society. In other words, applications, they all appear here. You have to do 5 out of the 9 questions, huge amount of choice. Okay, each question is worth 56 marks here. This is going for 70% of your total mark. The popular questions are question 6, where you do 8 out of the 12, question 13, where you're given an article and 8 short parts in that, and then question 14, where you have a lot of choice, you do 2 out of the 4. Once again, be prepared for questions that mix topics. For example, last year, question 11 had heat, sound, and radioactivity all in the one question. You will have to do calculation problems. Okay, make sure that you can draw a diagram to visualize what's happening. Write down what you're given and what you're looking for. Write down the appropriate formula, substitute in the formula. Show all your calculations. There is no such thing as rough work in a physics exam. Everything needs to go on the actual page. Don't forget those units at the end. You will lose marks if you have incorrect units or if you don't have any units at all. Use the next line approach, in other words, going down the page rather than going across. Okay. Timing, you should not run out of time. If you have planned, well then stick to your plan. Make sure you know where your exam is. Be there early. Have everything you need: pens, pencil, rubber, a clear ruler, calculator, and so on. Use black or blue text pen for your text, a soft pencil for the paper, for your diagrams and graphs. Start a new page for each question. If you don't get a question finished, leave space and go to a new page. Don't write in the margins. Remember that the booklet is going to be taken apart and scanned. Your work needs to be clearly laid out and easy to read. Number your answers as per the questions. Don't make up your own numbering scheme. Read each question carefully and answer what is asked. Not what you think is asked, what is actually being asked. Do have a go at everything within each question. If you have to guess, do so intelligently, but don't leave blanks within the questions that you actually choose to do. Okay, this is the timing, a suggested timing. With there being so much choice, it's important that you actually read the paper fully from cover to cover. Okay, deciding what ones are going to be your easy questions. Okay, most students will find the section A the easiest, and so you should allow 20 minutes for each question, doing your easiest question first. That's going to give you a total of 60 minutes. Okay, then when you have that section done, go to section B. Once again, do your easiest question. You may find when you get to some of your hardest questions, because your subconscious memory has been working on it, that they are actually easier. Okay, 10 minutes at the end to review all the answers and questions, and watch out for missing questions and for silly mistakes. Watch out for the units again. So read the question answer, your answer again before moving on to your next question. Do not leave an exam early. I've met students who have thought of things when they have left the exam. It's way too late at that stage. If you do have extra time, it's unlikely that you will, but if you do, maybe you would like to do some extra questions. And I would suggest in the short questions in question 6, or if you have considerable amount of time, in question 14, you might have enough time to do another half question. Okay. At the end of the exam, forget about it. Okay. Do not linger about the answers you've got. You need to think about your next exam. If this is your last exam, think about your summer. Okay, so some of the resources I have mentioned are available from this website, or indeed you can scan the QR code that's there available. I would like to thank my teaching colleagues for the use of some of these resources. I hope this has been useful to you. I wish you the very, very best of luck in your exams. Bye for now.